Okay, today we're going to work on simplifying expressions in order to solve equations. In the previous sections we've solved some simple equations, but now we're going to actually practice simplifying some expressions that are going to help us then be able to solve more complicated equations. So let's just get right into it and we'll just do some, take a look at some various expressions. What if you have something like 3x plus 17x? Can you simplify that in any way? Well, the way to really look at that is whenever you have things added together like this, look for like terms. And what I mean by that is look for variables that look the same. In other words, there's an x here and an x here, and there's nothing else involved except the numbers in the front there. So I can then simply, I have 3 x's over here and I have 17 x's over here, so I can add those for a total of 20 x's, which is 20 times x. And that is a simplified expression. So basically you look for like terms and then you simplify like that. Let's take another one. Let's say we have 8x squared minus 5x squared. Is this simplified? And if it's not simplified, how can we simplify it? Well, we have x squared here and an x squared here. So we have 8x squareds here and we have 5x squareds here. So you can think of, this thing as, you can kind of put it in terms of pencils if you want. This x squared is x times x, but it can be pencils, it could be umbrellas or whatever. And I have 8 of them here and 5 of them here and I'm subtracting. So it's just like regular math. 8 minus 5 is 3. But I'm dealing with x squares, so I've got 3x squares. So when you're adding and subtracting things that involve variables, you carry the variable through and you just simply add and subtract the coefficients. These are the coefficients just as you would do normally. Now let's take a look at something similar. Let's say you have 9x plus 3y. Okay. Well, you see we have an x here and a y here. So the bottom line here is you can't simplify that any further. Okay, that is simplified. There's nothing more you can do with this. I have 9 x's here and 3 y's here, and these are different. So I can't add 9 and 3. You're not gonna try to do anything with that. So basically, anytime you add things, they can be as complicated as can be, and we're going to get into some more examples. But you can only actually add the coefficients if whatever comes after is exactly the same, like the x squared here and like the x here. This is fully simplified. You can't do anything more with it. Let's say you had something like 3 parentheses x plus 2 close parentheses plus 4x. Well, this is a good example to use the distributive property. Let's go ahead and work on simplifying this thing. This is 3 times, and then the parentheses tells you this 3 is going to be multiplied times the entire contents here. And if you remember from an earlier lesson, you use the distributive property, so you're going to distribute the 3 in there, so 3 times x, and you're going to also distribute the 3 times the 2, because when it's in parentheses, 3 is multiplied by each and everything inside there. So I'm going to begin with 3 times x for 3x plus, because it's a plus, and I'm multiplying positive numbers. 3 times 2 is 6, and then I've got to continue on with my 4x because I haven't really done anything to it. So 3x plus 6 is what you end up with when you expand that out. Now what is this equal to? Well, the 6 is off by itself. There's nothing much you can do with it, but I have an x here and a 3x here and a 4x here. So these are what we kind of call like terms. They share, they're each consists of numbers multiplied by x. So I can add those together for a total of 7x, and then the 6 is just left over. I didn't do anything with it at all, so I have plus 6, and that is the answer. So this whole mess over here is simplified to 7x plus 6, and all we did was distribute the 3 in and then look for like terms. This looks similar to this because we have x's. I add the coefficients, I keep the x, and then the 6 is just left over. You really can't do anything with it. Let's say we have something like slightly more complicated. Let's say we have 5 parentheses z minus 3 close parentheses plus 2z. This is actually very similar. Well, let's go ahead and distribute this in. So I've got 5 times z, which gives 5z, I mean, it's not rocket science. It's 5 times z. Can't do anything else with it. And then when I distribute the 5 in onto the 3, this is a positive 5 times a negative 3 because I've got a negative sign here. Positive times negative is negative, so this has to be a minus sign. 5 times 3 is 15. Okay, and then I just got to carry the 2z plus 2z because I haven't done anything with it. And then this is simply equal to, I've got like terms here. This 5z is a like term with this 2z because they both have z's. 5 plus 2 is 7z minus 15. And that's the answer. So we just distribute this out, combine like terms. And like terms, they both have z. So that's pretty much going to be what we're going to do in this section. We are going to just work problems that deal with basically simplifying expressions, and we're going to be looking for like terms all day long and combining like terms. Okay, let's say we have something like this. X plus 2 minus x minus y. And I want to simplify that into something useful. Well, this is equal to, there's nothing multiplied by the x plus 2, so I'm going to go ahead and just write x plus 2 down again. I'm not going to change anything. I'm just not going to put the parentheses there. They're really not needed since there's nothing being multiplied out here. But in order to deal with this properly, you need to distribute this in. Okay, you can think of this minus sign as equivalently as a minus 1 times this thing. So you can't just this doesn't really help you the way it's written here. But in order to actually do the addition and subtraction, you need to distribute this minus sign. So minus 1 times x gives me minus x. I'm going to write that down. Minus 1 times minus y is equal to plus y, because negative times negative, negative 1 times negative y is equal to positive y, and you can go look back at our multiplication rules to convince yourself of that. Once you have this written down, it's easy, because you just look for like terms. Well, I have an x minus x. I mean, anything minus itself is 0, like 2 minus 2 is 0. X minus x is 0. So there's going to be a big fat 0 there. And then I just have a y, so I've got plus y, and then I got a plus 2. So the answer is y plus 2. And really, that's it. You just expand it out. The x's go away because x minus x is 0, and you're left with y plus 2. You could write the answer as 2 plus y. That's exactly the same thing. But generally, in algebra, you write the variable first. So since the same x plus y is the same as 2 plus y, y plus 2 is the same as 2 plus y. It doesn't matter which way I write it. I choose to write it with y first because that's sort of the established convention. Let's do something with fractions. Let's say I have 2 parentheses 4x plus 9 over 2 minus 3 parentheses x plus 2 over 3. Now, obviously, I'm going to have to do some distributive stuff here. I'm going to distribute this 2 into here, and I'm going to get some mess. And then I'm going to distribute this negative 3 into here, and I'm going to get some other mess, and then I'm going to be able to add these together. So let's do that. 2 times 4x. Okay, how do we do that? Well, it's just 2 times 4, which is 8 x's. I want you to think of this in terms of pencils. Sometimes it's easier. Just think, when you see x, just think pencils. 2 times 4 pencils is 8 pencils, so I'm going to write 8. You don't really do much to the x. You certainly don't put anything up in the exponent here. You just multiply. You're just multiplying the coefficients here. You get 8x plus 2 times 9 over 2. Well, I can tell you right now that these 2's are going to cancel because 2 over 2 is 1. So when I multiply this in over here like this, it's going to be 2 over 1 times 9 over 2. The 2's are going to cancel. I'm going to be left with 9. So I'm going to put a 9 right there. Now, I'm going to go work with this. Negative 3 times x is simply negative 3x. Negative times positive gives me a negative, and 3 times x is simply 3x. And then I'm going to work on distributing this over here. Negative 3 times 2/3. The 3's are going to go away the same way they did here. But since it's a negative times a positive, it's going to be a minus 2 instead of the plus over here. So I've got negative 3 times 2 over 3. The 3's cancel because 3 over 3 is 1. But I've got a negative. I've got to keep it. So I'm left with this mess. Now I'll just look for like terms. This is a like term with this. 8x minus 3x. I just subtract the coefficients, which is 5x, because 8 minus 3 is 5, and then of course this is a like term with this because they're just numbers, so that's going to be plus 7 because 9 minus 2 is 7. So the answer is 5x plus 7. So you can see it's pretty ugly looking at first, but you just distribute things in, collect like terms, and you end up with that. Okay. Let's start to solve some equations. And we're going to be simplifying some expressions along the way in order to help us solve the equations. So let's say we have 3x plus 2 is equal to 2x. Okay? And I want to solve this equation for x. There is a value of x that when I plug it in here makes this equation exactly satisfied. I want to isolate x on one side of the equal sign and have everything else on the other side. Well, first of all, I've got some 3x's over here and I've got 2x's over here. I've got to get them together somehow. So I'm going to do my best to move this 2x over here. How can I do that if I want to get these 2x's together? Well, if I subtract, remember whatever I do has to be done to both sides of the equation. If I subtract 2x from both sides, if I were to do that, I'd be left with 0 on the right hand side, because 2x minus 2x is 0. 2x minus 2x is 0. And then I just have 3x minus 2x over here. So let's go ahead and do that part. Let me just draw an arrow. We're going to continue over here. I'm going to have 3x plus 2, which is what I started with, minus 2x equals 2x minus 2x. All I did was this is the new term here, and this is the new term here. All I did was subtract 2x from both sides. On this side of the equal sign, this goes to big fat 0, because 2x minus 2x is 0. And on this side of the equal sign, I'm going to continue over here. 3x minus 2x, they're like terms. Both have x's, and 3 minus 2 is 1. So I'm left with 1x, which is just simply x. And then I've got a plus 2, so I'm going to go ahead and put a plus 2 equals, and then what I was left with on this side is 0. So far all I've done is transform this equation, 3x plus 2 equals 2x. I've transformed it to x plus 2 equals 0. And I want to just point out and make it crystal clear that these two equations, the one I started with right here and the one that I'm currently working on here, are exactly 110% equivalent to one another. They look different, but they are exactly the same. And the reason they are the same is because I performed an operation to both sides. It's like a scale. You have a scale here, or a teeter-totter or something like that. And here's some stuff over here, and here's some stuff over here, and this is the equal sign. And as long as I add, one basketball over here, and I add one basketball to here, the equal sign is left intact. Nothing changes. If I add two basketballs over here, everything is exactly equivalent. As far as the teeter-totter, it stays equal. So this is exactly the same as this algebraically. It just looks different. Now, in order to get the answer, I want to get x by itself. So in order to do that, I'm going to do the opposite of this addition. I'm going to subtract 2, which is going to give me x plus 2 minus 2 equals 0 minus 2. All I did was subtract 2 from both sides. Now this time, the 2's go to 0. Okay? And so I'm left with x on the left equals 0 minus 2 minus 2. And this is the answer right here. X is equal to minus 2. And that is exactly the answer. So all you do is you use the rules. That's what I'm trying to say. There's multiple ways to solve these problems. And there's just no way around that. You might do a problem on a test. The teacher might work it a little bit different. That's okay, as long as you know what is legal to do. As long as you don't start doing crazy things and not doing it to both sides. It's like artwork or something. You can do it any which way you want as long as you are legal. Okay, let's try this one. Let's say we have, this is an equation, 3 parentheses a plus 2 equals 4a. Okay. Now, the first thing we need to note, we want to solve for a, obviously. The first thing we need to note is that I've got this big parentheses here, and there's no way I'm going to be able to solve for a with this stuff tied up in the parentheses. So I'm going to use my trusty distributive property. I'm going to distribute 3n to there and to there, and I'm going to expand that out. So let's do that. 3 times a is simply 3a. Pretty easy. Plus 3 times 2 is 6. Okay? Equals 4a. I'm not going to change anything on the right hand side yet. Now it looks similar to other problems. I'm going to move the 4a over here, and I'm going to move the 6 over here, and then we're going to see where we end up. So let's do that. Let's subtract 4a from both sides of this equation. I already know when I subtract the 4a, I'm going to get 0 on this side. So I'm just going to write 3a plus 6 minus 4a equals 0. Now I could have written over here equals 4a minus 4a, but I know it's going to be 0. That's the entire reason I'm subtracting it. So I'm just going to put 0. And let me simplify this. 3a minus 4a is equal to negative a plus 6, that doesn't change, equals, once again, 0. Okay? And the reason that I get a negative a here is because, you know, 3a minus 4a, the bigger number has a negative sign, so the answer is going to be negative, and since I've got mixed signs here, 4 minus 3 is 1, so I've got 1, and a is still involved here. You always got to keep that along. Okay? Now, how can I get a by itself? Let me just move a over here. Currently I have a negative a, so I'm going to go ahead and add a to both sides. Negative a plus 6, 6 doesn't change, equals 0 plus a. Negative a plus a simply gives me big fat 0. That's why I did it. And so on the right hand side, on the left hand side I am left with 6. On the right hand side I am left with a. So 6 equals a, or you can just turn that around. A is equal to 6. You can flip those around. So a is equal to 6 there. So it's really not that bad. You just got to work with it a little bit. That's going to end part 1 of this video topic, and we'll pick it up here in just a few moments with part 2 of simplifying equations, and the problems will get a little bit more tricky as we go.